Hi, my dear intermediate students, MPC students, BPC students, NEET aspirants, IIT aspirants, CBSE plus 1 students, CBSE plus 2 students. Good morning to all. This is Mr. Bhanu Moorthy Sharma, SRUSHTI Bhanu Moorthy Sharma. SRUSHTI is my surname, of course. I'm a senior most physics lecturer in Hyderabad, having 28 years of teaching experience in Hyderabad. I established one academy, BMS Academy of Physics, and I'm conducting online classes, offline classes for NEET entrance examination as well as IIT JEE entrance examination. I established this institution in the year 2018 and conducting online, offline classes. Maximum number of students are hearing my classes. I'm taking offline classes, conducting offline classes for the nearby students who are coming to my house from nearby areas around Vanasthalipuram. And also I'm conducting offline classes, online classes for the students, distant students, not only from Hyderabad and all over India. They are hearing my online classes. So, online classes separate batches, offline classes separate batches I am conducting. I am not disturbing your regular intermediate college hours. So, I am conducting the classes in the early morning hours from 4:30 to 7:30, 3 long-term batches. And in the evening hours from 4:30 to 9:30, every 1 hour I am conducting batches or long-term batches, NEET as well as IIT batches. So this is my information, my dear students, NEET aspirants and IIT aspirants. Today, this is the 4th video class that I am going to present. The students and parents requested me to present some concepts from current electricity in this video class number 4. I know that students and parents are eagerly waiting for my 4th video class. So on the behalf of their request, I want to project, I'm projecting now 3 examples from current electricity very quickly in this video class number 4. Okay, let us go to video class number 4 quickly from current electricity Kirchhoff's laws I am expecting. Okay, what is meant by Kirchhoff's laws? Why we are discussing Kirchhoff's laws first of all? So actually you know better about Ohm's law in current electricity. What is the use of Ohm's law? For simple circuits, there is only one cell, one resistance, okay, that is called as simple circuit. In simple circuit, we can calculate current from the circuit. How much current is flowing in the circuit? We can calculate using Ohm's law. But in complicated circuits, having more than 2 elements, say more than 2 EMF cells, more than 2 resistances. So that type of circuit is called complicated circuit. In that complicated circuit, Ohm's law is only not enough to calculate the current. So, Kirchhoff, name of the scientist, implemented some rules, some laws, 2 laws. Along with Ohm's law, he implemented 2 laws to calculate the current in the complicated circuit. So, that is the purpose of using Kirchhoff's laws. Generally, the students don't know. They don't know how to, the importance of Kirchhoff's law. But they will do the problems in the colleges also. But actually, concepts, basics are required. Why we are using Kirchhoff's law? To find the current in the complicated circuit. That's all. Okay? Along with Ohm's law. Now I am projecting one example number 1 based on Kirchhoff's second law. Okay? So this is one terminal A and this is one cell of EMF 9 volts. This is resistance 2 ohms, second resistance 4 ohms, cell, another cell, this is 6 volts, another resistance say 6 ohms. This is the terminal number 2, B. First cell is having internal resistance, say R1 equals to 0.5 ohms. Second cell is having internal resistance 1 ohm. And some current is flowing in the circuit, that is 3 ampere. My dear NEET aspirants and IIT aspirants, this problem plays an important role in NEET entrance as well as IIT entrance. This model is coming in examinations repeatedly, okay, this question. So this model is important, whatever the numericals it may be, but model is very important. So they are asking this model frequently in entrance examinations. Be careful. That is the reason why I selected this problem in this video class number 4, right? Okay. So find the potential difference. Find the potential difference between the points A and B. This is the question. Find the potential difference between the 2 points A and B. How to find out? So for our convenience, we are putting some symbols for those numericals. So this is E1, EMF of the first cell. This is E2, EMF of the second cell. External resistances, this is R1, this is R2, we are putting, and this is R3, we are putting. Okay, internal resistance, small letters R1, R2. Current is represented by I. So for our convenience, they won't give the symbols in the diagram. Okay, we are putting the symbols for our convenience. Now let us check how to find out the potential difference between the 2 points. Right? Now potential difference between 2 points plus algebraic sum of EMFs equals to algebraic sum of potential differences. My dear students, this is the formula. Based on this formula, we can calculate potential difference between the 2 points A and B. This we want. Okay. So VAB equals plus, what we have to write there? 9 minus 6. 9 minus 6 in this first square bracket. So sir, why we are putting plus positive for 9 and why we are putting negative for 6? There is a logic, that is a technique, okay, signed rule for EMS. So this cell is supporting the current. It is supporting the current. So it is positive. This cell is opposing the current. So it is negative. The cells which drive the current in the same direction, which support the current, their EMFs are positive. The cells which oppose the current, their EMFs are taken as negative. So these points are very important in Kirchhoff's law. Okay, na? So sign rule we can call it as. That is equals to, and algebraic sum of PDs, algebraic sum of potential differences. See, I into R1 plus I into R1, I into small r1 plus I into capital R1 plus I into capital R2 plus I into capital R3 plus I into small r2. Potential difference, that is IR. IR represents potential difference. Sum of all these potential differences. Okay, this is a method. Okay, now? So VAB plus 9 minus 6 is 3. I into small r1 is what? 1.5. Plus I into R1 is 6, plus I into R2 is 12, plus I into R3 is, what is that? 18, plus I into small r2 value is 3. Right? All the symbols are given there in the diagram. So finally we can get out VAB equals to. This is the method. My dear students, NEET students and IIT students, CBSE students, listen carefully this problem. This is very important problem in current electricity from Kirchhoff's law. Very important model, okay? Right. Frequently they are asking this model from in entrance examinations. So this is my way of teaching, okay? Shall we go to second example now immediately? Okay, right. My dear NEET students and IIT students, generally the students are not able to understand physics concepts now because of lack of concentration, because of lack of awareness in the subject, because of lack of explaining power in respective colleges. So because of so many reasons, they are not in a position to solve the numerical problems in respect to entrance examinations. So as a result, what happens, the students get afraid of physics. They feel that physics is a tough subject. They feel that physics is a tough subject. But don't worry, my boys and girls, I am here, no fear at all. Bhanu Moorthy sir can explain each and every problem in detail. Okay, I want to project one more point here. In this current electricity, nearly 40 to 50 models are there. This is one of the models, only one model I projected. Like that, 40 to 50 models are there in current electricity, especially this chapter. So, if you join in this institution, then each and every model we can discuss in detail. Once you get the confidence level, you can solve each and every problem clearly. Okay, right. Let us move to second example now, right? Example number 2. One problem I will give to you because it is came in entrance examination. How to solve the method? How to solve the problem? Okay, my dear students, this is the method. Now 6 amperes current is flowing here and it is divided into 2 parts like this, right? This is the circuit given to you. Now asking what? Asking what? Find the current I1 and I2. I1 question mark, I2 question mark. Find the currents in this circuit using Kirchhoff's laws. Right? How to find out? I am first selecting Kirchhoff's first law. My dear students, do you know Kirchhoff's first law? Law of currents. What is law of currents? Sum of the currents flowing towards this junction. This is the junction. Sum of the currents flowing towards the junction is equals to sum of the currents flowing away from the junction. So one current is flowing towards the junction. 2 currents are flowing away from the junction. So, 6 is equal to I1 plus I2. Equation number 1. That's a very simple problem. It is okay. So, Kirchhoff's second law I am implementing now. Kirchhoff's second law is what? So, algebraic sum of EMFs equal to algebraic sum of potential differences. Right? So, algebraic sum of EMFs means 0. No cells are there. Okay? No cells are there. Okay? Sum of EMFs. Kirchhoff's second law I am implementing now. So, sum of EMFs is equals to sum of PDs. That's all. Simple problem. So, sum of EMFs equal to 0 because there is no cell in the circuit, you know. Right. Next, equals to sum of PDs. PDs means these two are in this direction. This is in this direction. These two are anti-clockwise currents. This is clockwise current. Sum of anti-clockwise currents as well as clockwise currents. So algebraic sum that is. Okay. So I1 into 2, I into R plus I1 into same current is flowing here also. I1 into 2, I1 into 2. So I1 into R1 plus I1 into R2. Sum of these two potential differences. I1 into R, I1 into R. Okay. This is minus because this is minus. Okay. Minus clockwise. Sum of clockwise currents are negative. Okay. So this is I2 into 2. Remember one point. Potential difference also one sign rule is there. Okay. So anti-clockwise potential difference is positive. Clockwise potential difference is negative. Sum of all. Okay. Positive and negative. Right. So 0 equals to, what is this? 4I1 minus 2I2. So 4I1 equals to 2I2. Therefore I2 equals to 2I1. If you substitute second equation, substituting 2 in 1, what you will get, my dear students? If you substitute second value in first equation, what you will get? Okay, 6 equals to I1 as it is plus I2 means 2I1. So equals to 3I1. Therefore I1 equals to 2 amperes. If you get I1 2 amperes, I2 automatically 4 amperes, okay? Because I2 is twice I1. So this is a method, my dear students, NEET aspirants and IIT aspirants. So this is the way of approaching this answer. So we are implementing Kirchhoff's first law at this junction, and we are applying Kirchhoff's second law in this mesh. So it's a very, very important model because two laws are implemented here, right? Shall we go to next example to understand Kirchhoff's law? How to imply Kirchhoff's law in the given problem. That's all. So this is the second model, I think. This is my dear students. So from each and every chapter, nearly 30 to 40 to 50 models will be there. If you go through all those models from this academy, from me, then you will get seat in the convener quota. Remember this point. Example number 3 I am doing. I am projecting one circuit to you like this. Ten ohms resistance. Okay, my dear students, this is the method to understand how to find out. Okay, this is the diagram given to you. Find the current flowing. Find the current flowing across 10 ohm resistor. Find current flowing across 10 ohm resistor. This is our question. Circuit is given to you. So 10 ohm resistor is here. Two cells are there, one resistance is there, two internal resistances are there. So it's a complicated circuit, right? So find the current through this resistance, through this resistor. This is the question. Now solution I am doing. This is R1, this is E1, this is E2, this is R2. Okay, for our convenience, we are putting the symbols on those numerical values, right? So if I current flows in this mesh, at this junction, I divide it into two parts. Some current I1 flows through 10 ohm resistance, and remaining I minus I1 flows through this one. That is our assumption. They won't give any problem. Okay? So our assumption, if I1 gone here, remaining rest of the current I minus I1 here. So you have to assume like that. Okay? No? Right. So two meshes are there. This is mesh number 1. This is mesh number 2. So in mesh 1, what is that? Sum of EMFs equal to sum of PD. Same method again. Okay. Sum of EMFs means 7. This mesh is A, B, C, D, E, F. We are putting like this for our convenience symbols. Okay. So from this mesh A, B, C, D and A, in this mesh number 1, sum of EMFs means 7 equal to sum of PDs. Sum of PDs means I into R1 plus I1 into 10. That's all. Okay. Two resistances are there. One current is there. I into R1 plus plus I1 into 10. Product of these two plus product of these two. Okay. So then what happens now? 10 I1. I1 into 7 equals to I into 2. So 2I plus this is 10 I1. This is equation number 1. My dear students, let us see this mesh also. This mesh is B, E, F, C, B. B, E, F, C, B again. First mesh is A, B, C, D, A again. So we are applying what? Kirchhoff's second law. Kirchhoff's second law we are applying to this mesh and to this mesh. Yes, that's a very simple. Okay, so B, E, F, C, B. From this mesh, So we can write number of EMFs equals to, what is that? 3. Sum of EMFs equal to 3. Equal to sum of PDs. Sum of PDs means what? So I minus I1 into R2. I minus I1 into R2. Okay, this is one potential difference. And second potential difference, reverse. Reverse means what? Minus. Okay, this is in this direction and this is in this opposite direction. So they are opposite. That's why minus it is. Minus 10 into I1. I1 into 10. So 3 equals to, so I into R2 value 1 no. So I minus I1. So minus 10 I1. R2 value 1. Okay. So 3 equals to I minus 11 I1. So this is equation number 2. So solve these two equations. Solving 1 and 2. We get what? We get I1 value. Okay, current passing through 10 ohms. This is a method, way of approachment. Okay, so first mesh, selected this formula. Second mesh, selected this formula. Kirchhoff's second law formula. So sign rules of EMFs, sign rules of potential differences. So we can discuss in detail in regular classes in this tutorial academy. My dear students, the students will suffer a lot. They are facing so many difficulties in understanding physics concepts. So in regular intermediate colleges, so they are suffering a lot while understanding, because in one class nearly 70-80 students are there. So proper attention will not be there. That is the reason why the students are searching for tutorials now. That too, well experienced tutorial master they are searching for. So this is the best academy. We are having full experience now, 28 years of teaching experience. So avail this golden opportunity, their way of approachment, the way how to, we will come down to the students level actually. We reduce our level to the students level, and we can understand the students' psychology, and we can explain in such a way. So that all the students, in each and every batch, nearly 15 students are there. I'm not taking more than 15 students in every batch. So that's why individual attention will be there. So I can understand that which student is doing well. So how the students are solving the problems. I can put my individual attention on the students if there is a limited strength in each and every batch. So that is advantage. So my dear students, please avail this golden opportunity. Take advantage and try to gain the subject. So your duty is to join in this institution, and my duty is to give the subject to you. Okay, so all models let us discuss, all applications let us discuss in each and every one, from each and every chapter. Okay, so application point of view, very important. The students are afraid of physics. No need to worry. So no need to worry here. Again, I am stressing. Don't fear, I am here. Okay, we can discuss in each and every one. So contact these numbers quickly. Okay, and reserve your seat immediately. Limited strength is there in each and every batch, in the early morning classes and evening classes after your college timings. Okay, you can join in this institution. I am conducting only physics classes now. Okay, so this is my own house. Okay, I am not working in any institution. I have only my own academy. Okay, so my concentration is to project as maximum models as possible to you, so that you can gain the subject and you can get the seat in entrance examinations, because this academy already produces so many ranks in entrance examinations. So in convener quota they got a good ranks in convener quota. Okay, so this is the most prestigious institution, well experienced institution. Avail this opportunity. Let us meet in 5th video class now. If you are interested to join here, and then you please like, share, subscribe this video and press the bell button. Don't forget that. Okay, now, and do viral these videos to all your friend circle. Right now, see you. Bye in the next video class. Bye bye.